Madam Speaker, ladies and gentlemen, since the dawn of human existence, science, technology, and engineering have served the purpose of pushing humanity farther and farther in order to explain the world around us using the scarce resources we have that shape the world. I don't think the previous speaker really understands the deeply embedded importance of economics and finance in modern engineering because there exists trade-off and opportunity cost. Money doesn't grow on trees, and in order to re-engineer and examine the entire supply chain or value chain of a particular product or service or industry or infrastructure costs a huge amount of time and money that we otherwise might not afford, and even if we could, essentially gatekeeps it only to those who are able to do it. The pump I have is simple. What got us here today may not necessarily be the same things that will get us there tomorrow. We have to understand that the scientific method in itself, which is a cornerstone of modern engineering, in and of itself is iterative in nature. Meaning, in order to be able to learn, in order to be able to understand how to improve certain things, we need to be able to consult, we need to be able to ask, and we need to be able to learn from those around us because we stand on the shoulders of giants. On their side, people are motivated to do things themselves that essentially creates a risk wherein are these people really going to be able to know what to do? And even in instances where they can, there's no incentive structure to be able to truly share that innovation with the world. And you essentially have a huge amount of redundancy wherein all of these people are drowned into this illusion that, yeah, brah, I'm going to go Elon Musk and visionary. I'm going to lock in and change this myself. But we think that the whole is greater than some of its parts. And ultimately, on our side, you get more efficiency and more innovation. Make no mistake, laws from first principles, like the theories and all of these formulas, etc., are important, are valid, and are seminal. We're going to use it, but they're merely just a building block and operating system. This debate is primarily about what lens do we look at through modern engineering, and we think that that lens is particularly through iterative discovery, which is better in terms of innovation and involving more people as we shift into a more multipolar world that hedges against a single point of failure that can happen when you have shitty leaders or delusional individuals thinking that they can do everything. A couple of things that stand on side opening opposition. The first is a very clear comparative trade-off so that this debate is good. The first principles, which we understand, do involve a deeper sense of control when you're able to, sure, try and look at the whole picture and understand the value chain from raw material to finished good, from silicon to the iPhones and laptops that we're using in this debate. Government side, sure, has more control, but on opposition side, we think that we're willing to give up that control for a sense of collaboration and iteration that paves and lubricates the way for proper innovation. Let's examine Elon Musk, right? Let's understand how that works. Elon Musk is a visionary and entrepreneur, but he is an outlier rather than a rule. How many Elon Musks are there? One. How many people are there on the planet? Meaning, it's safe to say that, yes, some people are dope, some people are not so dope, but on average, people are kind of mid, right? That is to say, first principle thinking, we think, are not necessarily catering to those people who are mid. Because if you expect these people to have the means, motivation, and capacity to be able to spend a lot of money, time, and resources to even diagnose that particular problem, and at the same time, trying to be able to build that whole thing from freaking scratch, in and of itself is kind of hard because they might not be able to do it. But here's the kicker. Even if they can, it becomes a huge redundancy and waste of time, wherein you have a creation of an outcome and path dependency on their side that these people really are going to be able to do it. But in instances that it becomes difficult, wherein you can't afford to be able to pay anymore, that particularly becomes problematic. Because let's take a look at SpaceX, bro. SpaceX on average loses money. Elon loses money sending all those rocket ships to space, but he can only afford it because he's a billionaire, meaning he makes enough bank from Tesla to be able to bankroll his particular passion project for SpaceX. We think first principle design thinking, when you primarily think and believe you can control the entire chain, in and of itself is ultimately anti-mid in terms of thinking, and it's also anti-poor or anti-average because it takes a huge amount of money and outlay to be able to have the capital to literally be able to do those things. That is why on our comparative, we have vertical and horizontal integration that literally are able to collaborate with all sorts of other people who have done it and who can do it better. Sure, POI, go for it.
How then will these mid people supposed to collaborate with the experts?
They ask the experts and they iterate through what the experts have done. On your side, you create a redundancy wherein experts who have the means, motivation, and capacity are also doing it, and all these other mid-normal people in science are also expected to do the same thing. That in itself is not efficient and undermines fundamentally the whole point of modern engineering, which is to be able to make solutions to be able to change the world around us. Uniquely coming from opening opposition, what we get is that an examination of these particular first principles, given that these things are hugely intensive in terms of resources, it particularly stifles the ability of people to participate in innovation. Because we think on our side, we're actually able to do things cheaper and better at the point in which we're able to create a capitalist and mutually beneficial incentive structure with other people who failed, other people who got it right. You actually have a means for those who got it right to be able to partner and sell those solutions with other people. Case in point, joint ventures we have in order to be able to build bridges with the Japanese who have perfected those technologies. Joint ventures with the Americans who understand how nuclear power has in order to be able to take a look at how we can rehabilitate the Bataan nuclear power plant. Joint ventures with the Koreans who understand technology and actually have the capacities to be able to sell us that technology at a cheaper price for us to be able to do it, and in order to build the beautiful and grand city centers that we see as we push modern engineering to its fullest capacity. Ladies and gentlemen, on their side of the house, sure, you have more control, but we think being able to do these things and democratize access to people is particularly good. We are very proud to stand on side negative.